So, OpenAI decided to skip right over O2 and went straight to the O3. Guess they couldn't wait. As part of their 12th day of the 12 days of OpenAI, they've just dropped a major update, introducing the O3 and O3 Mini. Totally unexpected, especially since they just launched the O1 Pro a week ago. But the O3, it's absolutely mind-blowing. It scored a whopping 87% on the ARC AGI benchmark, which means it's performing at near human level across the board. We're seriously getting closer to AGI here, and that's pretty wild. So, this is the ARC AGI test, and it is known as the unbeatable test. Few AI models have scored even 5% on this test. The new 0.3 model scores in the 76% range for the low usage version and 88% for the high tune version. That's really insane. For context, the O1 preview and O1 high versions were under 35%, with O1 mini only at 8%. Other models like Claude aren't even close. Historically, AI developers like OpenAI and Anthropic have avoided this test due to how bad it made them look. But OpenAI not only embraced the test, they brought the president of the ARC Foundation to explain it.
Hello, everybody. My name is Greg Kamrad, and I'm the president of the ARC Prize Foundation. Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about what ARC AGI is. So I would love to show you an example here. ARC AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now, the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border effect with.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations to that.
Thank you so much, yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this O3 world. But the work also is not over yet, and these are still the early days of AI. So we need more enduring benchmarks like ARC AGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Hey, if you're enjoying this video, I just wanted to say, you can now support the channel using the Super Thanks option below. It's a simple way to help us keep creating and means a lot. Thanks so much. There will be 2 sets of new models, the O3 and the O3 Mini. As of now, the models aren't available just yet, and the pricing hasn't been fully structured. However, the O3 high-tune model is expected to be priced around $1,000, which is pretty pricey. This model also has a self-evaluation capability, enabling it to write and execute scripts to evaluate its own performance. This showcases its adaptability, which is why it is performing so well in terms of the ARC AGI benchmark. There's also improved latency, where the low reasoning effort mode shows near instant response times, comparable to even GPT-4 Turbo.
So I'm testing out O3 Mini High first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this like Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call O3 Mini API, and O3 Mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
Very complicated.
pretty complicated task, right? And it outputs like a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah, I see.
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great. We have a UI where we can enter some coding prompts. Let's try out a simple one, like print OpenAI and a random number. Submit. So it's sending the request to O3 Mini Medium, so it should be pretty fast, right? So on this
41.
terminal, yeah, 41. That's the magic number, right? So it saves the generated code to this like local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask. Just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI. So in this task, we asked the model to evaluate O3 Mini with the low reasoning effort on this hard GPQA data set. And the model needs to first download the raw file from this URL, and then it needs to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the O3 Mini with low reasoning effort. Yeah, let's see how it goes.
I guess 2 tasks are really hard here.
Yeah, the long tail is often the problem.
Go, go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results.
Oh,
it's 61.62%, right?
Amazing.
62%, right?
Cool,
With a low reasoning effort model, and it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to like just ask a model to evaluate itself like
Yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
As we wrap up, it's clear that this test is a critical benchmark for detecting breakthroughs in AI, but it is not an acid test for AGI. Passing this test doesn't mean AGI has been achieved. In fact, the O3 still struggles with simple tasks, showing it's not yet AGI. The upcoming test 2 will likely challenge the O3 even more, proving that the path to AGI is still far from clear. But with each step forward, we're getting closer, and the future of AI is looking brighter than ever. Well, that wraps it up for today. Thanks for watching, and until next time, keep exploring.